What is the purpose of using acid-base indicators in titrations? A. To determine the equivalence point. B. To measure the pH of the solution. C. To detect the presence of a certain ion. D. To act as a catalyst in the reaction. The correct answer is A. Acid-base indicators change color at or near the equivalence point in a titration, helping to determine when the reaction is complete. Which of the following is a characteristic of a strong acid? A. Weak electrolyte. B. Partially dissociates in solution. C. Completely dissociates in solution. D. Low acidity. The correct answer is C. Strong acids completely dissociate in solution, leading to a high concentration of H-Joe ions. What type of titration is typically used to determine the concentration of a strong acid with a strong base? A. Acid-strong base titration. B. Base-strong acid titration. C. Redox titration. D. Complexometric titration. The correct answer is A. In acid-strong base titrations, a strong acid is titrated with a strong base to determine the concentration of the acid. Which type of titration is suitable for determining the concentration of a weak acid with a strong base? A. Acid-strong base titration. B. Base-strong acid titration. C. Redox titration. D. Precipitation titration. The correct answer is A. A weak acid is typically titrated with a strong base in an acid-strong base titration to determine its concentration. What does a neutralization curve represent? A. The pH change during a titration. B. The rate of reaction during a titration. C. The color change of the indicator. D. The volume of titrant added during a titration. The correct answer is A. A neutralization curve shows the pH change of the solution during a titration, usually exhibiting a steep slope at the equivalence point. Which indicator is commonly used in strong acid-strong base titrations? A. Phenolphthalein. B. Methyl orange. C. Bromethymol blue. D. Litmus. The correct answer is A. Phenolphthalein is often used in strong acid-strong base titrations, changing color around pH 8.2 to indicate the equivalence point. What is the primary function of a buffer solution in titrations involving weak acids or bases? A. To provide color change. B. To resist drastic pH changes. C. To accelerate the reaction. D. To decrease the concentration of ions. The correct answer is B. Buffer solutions help maintain a relatively constant pH by resisting drastic changes, crucial when titrating weak acids or bases. What type of titration is commonly used to determine the concentration of a weak base with a strong acid? A. Strong acid strong base titration. B. Weak acid strong base titration. C. Weak base strong acid titration. D. Strong base strong acid titration. The correct answer is C. Titration of a weak base with a strong acid is classified as a weak base strong acid titration. Which type of titration curve would display a sharp and sudden pH change at the equivalence point? A. Strong acid strong base titration. B. Weak acid strong base titration. C. Weak acid weak base titration. D. Strong base weak acid titration. The correct answer is A. In a strong acid strong base titration, the pH changes sharply at the equivalence point. What is the primary advantage of using a buffer solution during titrations involving weak acids or bases? A. Enhances color change of indicators. B. Maintains pH stability despite additions of strong acids or bases. C. Hastens reaction rates for faster titrations. D. Reduces the volume required for titrant addition. The correct answer is B. Buffer solutions help maintain pH stability during titrations, preventing drastic changes. Why is it crucial to select an appropriate indicator for a titration to ensure accurate endpoint determination? A. To speed up the reaction kinetics. B. To enhance the color of the solution. C. To maintain the pH of the solution. D. To accurately detect the endpoint of the titration. The correct answer is D. Choosing the right indicator ensures a clear detection of the endpoint, leading to accurate titration results. What is the purpose of calibrating pH meters in acid-base titrations? A. To ensure accurate pH measurements during the titration process. B. To determine the concentration of the titrant used. C. To calculate the equilibrium constant of the reaction. D. To adjust the equivalence point of the titration. The correct answer is A. Calibrating pH meters is essential to ensure accurate pH measurements throughout the titration process, allowing for precise endpoint determination. What type of titration curve is most likely to exhibit a gradual slope around the equivalence point? A. Strong acid with strong base. B. Weak acid with strong base. C. Strong base with strong acid. D. Weak base with strong acid. The correct answer is B. Titrations involving weak acids with strong bases typically result in gradual slopes around the equivalence point due to the partial neutralization of the weak acid. The primary function of a buffer solution in titrations with weak acids or bases is to A. Maintain a constant pH despite the addition of small amounts of titrant. B. Accelerate the reaction rate between the weak acid or base and the titrant. C. Change the color of the solution at the equivalence point. D. Increase the precision of endpoint detection. The correct answer is A. Buffer solutions help maintain a relatively constant pH by resisting changes when small amounts of acid or base are added, ensuring accurate endpoint determination in titrations involving weak acids or bases. Which of the following indicators would be most suitable for a titration between a very weak acid and a strong base? A. Methyl orange. B. Phenolphthalein. C. Bromethymol blue. D. Methyl red. The correct answer is B. Phenolphthalein, known for its gradual color change around the equivalence point, is ideal for detecting the endpoint in titrations involving very weak acids and strong bases. What does the pH at the half equivalence point represent in a titration involving a weak acid and a strong base? A. The initial pH of the weak acid solution. B. The pH at which half of the weak acid is ionized. C. The pH at the equivalence point. D. The pH where the indicator changes color. The correct answer is B. The pH at the half equivalence point corresponds to the point where half of the weak acid is neutralized, indicating equal concentrations of the weak acid and its conjugate base. In a titration of a very weak acid with a strong base, which indicator would be most appropriate for ensuring accurate endpoint detection? A. Methyl orange. B. Phenolphthalein. C. Bromethymol blue. D. Methyl red. The correct answer is B. Phenolphthalein, with its gradual color change near the equivalence point, is suitable for detecting the endpoint in titrations involving very weak acids and strong bases. What is the definition of an acid-base indicator in the context of titrations? A. A substance that changes color based on the pH of the solution. B. A substance that affects the rate of the reaction in a titration. C. A substance that increases the accuracy of endpoint determination. D. A substance that alters the stoichiometry of the titration. The correct answer is A. An acid-base indicator is a substance that changes color based on the pH of the solution. helping to visually determine the endpoint of a titration. Which of the following is a characteristic of a weak acid? A. Completely dissociates in water. B. Partially dissociates in water. C. Has a high pH in solution. D. Does not react with bases. The correct answer is B. A weak acid only partially dissociates in water, leading to a reversible reaction with the base in a titration. In a titration of a very weak base with a very weak acid, which type of curve is expected to be observed? A. A steep curve with a sudden pH change. B. A flat curve with no significant pH change. C. A gradually sloping curve around the equivalence point. D. An erratic curve with unpredictable pH changes. The correct answer is C. A titration of very weak species is expected to exhibit a gradually sloping curve due to the limited dissociation and neutralization. What does the half equivalence point in a titration represent? A. The point where the volume of titrant added is half of the equivalence point volume. B. The point where the solution becomes neutral. C. The point where all reactants are consumed. D. The point where the pH equals 7. The correct answer is A. The half equivalence point is where half of the moles of titrant required for the equivalence point have been added, indicating a specific volume in the titration process. What impact does dilution have on the shape of a titration curve in the context of a weak acid and a strong base titration? A. Shifts the equivalence point to a lower pH. B. Causes the curve to become steeper. C. Leads to a broader region around the equivalence point. D. Has no effect on the shape of the curve. The correct answer is C. Dilution can lead to a broader region around the equivalence point in a titration curve involving a weak acid and a strong base, affecting the shape of the curve. What is the primary function of a buffer solution when used in titrations involving weak acids or bases? A. To increase the rate of reaction. B. To alter the equivalence point volume. C. To stabilize the pH of the solution. D. To change the color of the indicator. The correct answer is C. Buffer solutions help stabilize the pH of the solution, preventing significant pH changes during the titration process involving weak acids or bases. Which of the following statements is true regarding the interpretation of neutralization curves in titrations? A. The equivalence point is observed where the pH is highest. B. The presence of a buffer region indicates the endpoint of the titration. C. Sharp pH changes suggest weak acid-base reactions. D. The midpoint of the vertical region corresponds to the equivalence point. The correct answer is D. The midpoint of the vertical region in a neutralization curve corresponds to the equivalence point where moles of acid equal moles of base, impacting the pH. What is the main difference between strong acids and weak acids with respect to their dissociation in solution? A. Strong acids fully dissociate in solution, while weak acids partially dissociate. B. Weak acids fully dissociate in solution, while strong acids only partially dissociate. C. Both strong and weak acids fully dissociate in solution. D. Both strong and weak acids only partially dissociate in solution. The correct answer is A. Strong acids fully dissociate in solution into their ions, leading to a higher concentration of H-Jod ions in the solution. Weak acids only partially dissociate, resulting in a lower concentration of H-Jod ions. What does the equivalence point in a titration represent in terms of the reactants and products involved? A. It is the point where both reactants are fully consumed, and only products are present in the solution. B. It is the point where reactants and products are present in equal amounts in the solution. C. It is the point where products are fully consumed, and only reactants are present in the solution. D. It is the point where the reaction rate is at its maximum. The correct answer is A. The equivalence point in a titration indicates the point at which both reactants are fully consumed, and only products are present in the solution, signaling the completion of the reaction. Which type of titration curve is expected to show a gradual slope around the equivalence point, indicating a weak acid and a strong base interaction? A. A curve with a sharp and sudden pH change. B. A curve with a flat region near the equivalence point. C. A curve with a gradual slope around the equivalence point. D. A curve with no observable changes in pH. The correct answer is C. In a titration involving a weak acid and a strong base, the titration curve is expected to exhibit a gradual slope around the equivalence point due to the weak acid's slower rate of reaction with the strong base. What is the primary role of an acid-base indicator in a titration process? A. Determine the initial pH of the solution. B. Detect the equivalence point. C. Neutralize the reaction mixture. D. Balance the chemical equation. The correct answer is B. Acid-base indicators are used to detect the equivalence point in a titration, marking the completion of the reaction. Which type of titration curve is likely to exhibit a gradual slope around the equivalence point, reflecting the interaction between a weak acid and a strong base? A. Sharp curve. B. Sigmoidal curve. C. Gradual curve. D. Vertical curve. The correct answer is C. A gradual curve around the equivalence point is indicative of a weak acid-strong base interaction where the pH change is not as drastic. When interpreting neutralization curves in titrations, what does the equivalence point represent in terms of the reactants and products present in the solution? A. Beginning of the reaction. B. Completion of the reaction. C. Halfway point of the reaction. D. Stagnation of the reaction. The correct answer is B. The equivalence point signifies the completion of the reaction, where the moles of acid and base have reacted in stoichiometric proportions. What does the half equivalence point in a titration of a weak acid with a strong base represent? A. Complete neutralization. B. 50% neutralization. C. No neutralization. D. Starting point of the titration. The correct answer is B. The half equivalence point corresponds to 50% neutralization of the weak acid, indicating halfway through the reaction. Which of the following is a distinguishing feature of a weak acid when compared to a strong acid in terms of their dissociation behavior in solution? A. Complete dissociation. B. Minimal dissociation. C. Rapid dissociation. D. Strong electrolyte behavior. The correct answer is B. Weak acids exhibit minimal dissociation in solution, leading to lower concentrations of H-Joe ions compared to strong acids. In a titration involving a very weak acid and a very weak base, which type of curve is expected to be observed due to the slow reaction rate near the equivalence point? A. Sharp curve. B. Gradual curve. C. Vertical curve. D. Sigmoidal curve. The correct answer is B. A gradual curve is likely to be observed in a titration of very weak substances due to the slow reaction kinetics near the equivalence point.